Hi, we're back with part 3 of Walking Down Memory Lane, talking about diagnostics. Check it out. Hi, welcome to the next episode of the On.NET Show. I'm Maoni, the owner of .NET Core Garbage Collector.
Hi, I'm Mukul from the Bing Performance team.
So, Mukul, last time we ended at talking about frozen objects, and I mentioned that you and I also did a bunch of diagnostics work in 3.0 timeframe. So I think that would be really interesting to talk about, especially for people who are really interested in how to figure things out, right? So I think this all started actually quite a way back when you either commented or started an issue on GitHub where you requested for a lightweight GC profiling API.
Yeah, maybe
right?
two or 3 years ago.
Yeah, two years ago. So tell me a bit about why you wanted it and all that.
So we've been, we have basically managed, as you can imagine, have a large memory workload, you'll have managed memory problems, leaks, and all sorts of things. And so one of the things we wanted to figure out is how can we use the GC profiling APIs without having to turn off concurrent GC, which the heavyweight GC profiling APIs do.
So that's a really a disadvantage because we definitely don't want you to turn off background GC. Right. So when you said that, I was like, I wholeheartedly agree. I want it too. And then years had gone by and nothing was happening. And then I think
I emailed you again.
Yeah,
one day or
like earlier this year, you sent me email. I think you had 3 things on it. This was one of them, and I just felt bad. I was like, gosh, 2 years had gone by and nothing is happening for this, and it's a simple thing to do. So I was like, I'm just gonna do it today. So I implemented that day and I checked today, and that sort of started our trend of adding new GC profiling APIs.
Correct.
And profiling APIs is really the only way that you can get a real-time diagnostics in, right? ECW and the eventing is not real-time, right? You cannot do something like when GC happens at this moment, I want to do something. Yeah. So the lightweight API gives you, real-time GC start and stop and generational ranges, right? So how are you using that in your environment?
Yeah, so the lightweight profiling APIs, which we've called, we're not the best naming experts, basic GC.
It's not our forte.
Naming
is not our forte.
It's not our forte. It's called basic GC. It's a flag that you turn on.
Right.
And what we use it for is getting ranges, which are really helpful for finding out things like, okay, where is our heap from beginning to end for all the different segments?
Yep.
Where for all the different GC segments, where is the data? Because you can kind of find out things like
because grow,
they grow, and it also tells you where the objects ended. So if you wanted to walk it, for example, you could do things like that. So we use it for just getting the idea of ranges, which we couldn't do with the previous API without disabling.
Exactly, yeah. So that was really helpful. And then from there, you started adding a bunch of new profiling API support. I think the next one that you added was medium weight.
That's right.
GC
As we said,
API.
we're not naming experts. We added the medium weight API. The medium weight API is mutually exclusive from the basic. So if you wanted,
you need to enable both.
Right. You have to enable basic and this medium weight. And the medium weight API basically gives you actual information about object movements. So when an object moves in GCs where it does move, you get that information.
So you only get this during compacting GCs.
You only get this during compacting GCs, and then you actually will be able to do, if you wanted to write a profiler tool that did memory leak detection, this is now possible.
Right.
Again, without disabling concurrent GC.
Exactly, which is very nice.
Which is very nice.
And I think, we talked about frozen objects last time, and one of the things that you had to do obviously was to, given the object you wanted to walk as references, right? So you also added an API for, doing just that.
Right. So when I started on the frozen objects stuff that we talked about last time, I was wanting to enumerate object references, and I said, hey, profile API makes exact sense. It will be useful because you'll be able to pause GC and just enumerate the objects from there. There does exist an API which is sort of cumbersome, which was cumbersome for me to use, which basically gives you all objects that survived or moved and all their references. So it was kind of awkward.
Right. I think we just packed up everything in a buffer, right?
Yeah.
So if you want to know a particular objects references, you kind of have to go through that buffer and pick out the ones that you care about.
And sort of the buffering was an impediment because you were buffering for every object, all its references.
Yep.
So the new API that I added essentially allows you to enumerate object references just the way the GC does, and have you get called back for each reference, without having to buffer up anything. And you can do it for the object that you care about. So an object of interest, you can just enumerate its
just
references.
That one, yeah. So, but also as we talked about last time, that all your frozen objects code was in managed code. So it turned out that you actually didn't use this API. So can you talk a bit about that, like why you didn't end up using it?
Yeah, so I didn't end up using it because with the idea of like you wanted to make frozen objects already an experimental feature that we want to get traction, having to require the profiling APIs be a thing in your tool was an impediment. So we basically said, hey, it'd be easier to just have
it's like a
implemented managed code.
Add-on, right? It's an explicit addition that you have. Now you have another DL that you have to load.
Plus, you may have had a profiler running already, and so it was a cumbersome
So that's interesting because even though you didn't end up using it, I thought it was still useful to keep it in the product, because if you're already a profiling company, right? Your company's product is a profiler. We have quite a few of those, and you're already using the GC profiling API anyway. So now you have a much faster way and much more convenient way to enumerate object references.
Right, and the customers of said tools would also benefit because now they wouldn't be told you have to run. If you want to use our profiler with these features, you have to disable concurrent GC. Now you can use it anywhere you want, and you can disable and enable and disable it at will as your application is running.
Exactly. Yeah. So what else did you add? I think you also added a large object allocation API.
Yeah, actually, talking about frozen objects, I also added an API that tells you if an object is frozen or not. Because now that we're expecting people to start using frozen objects, and there'll be a lot heaps that may have it, you want to be able to diagnose. And profiler authors would want to know, this object is frozen. I would never want to maybe go through its object references because we know this is going to be...
You want to treat it differently from the read-write objects.
So you can actually now find out if a object is frozen, and then you can essentially find the frozen segments as well.
Right.
And then the LOH stuff, because now in 3.0, the LOH...
it is configurable. The threshold is configurable.
Yeah. You can increase the size. So I was thinking, wouldn't it be cool if we could just get object allocation events for LOH, for large objects?
Right, because if you get it, because right now we do have profiling APIs that allows you to just get it for every object allocation, right? And that's, you can imagine the amount of overhead that adds, because we have these really fast, allocation helpers to handle the non-large, the small object heap objects. And now by enabling profiling, the allocation APIs, they go through slow helpers, but large object allocations already needed to go through a call, so you can just have it hook up there, right there. So that's that makes much more sense, to have a specific option for this.
If you wanted just to care about, if you were a team trying to improve your LOH allocations, you could just enable this. You only get the LOH allocations. You can, and if you configured it to a higher number, let's say you decide even 85 kilobytes, which is the current size by default, is too high, you could set it to 200 and use that as
too low.
Yeah.
Right. Yeah. So
if the number is too low, you can enable it to too high.
Right. So you can imagine a way of doing this perf diagnostics is you could set it very high. So only if say you're allocating if you allocated a few 250 megabyte objects, you can just set the threshold there. So you only get the profiling API to tell you about them. So you can make a determination do I want to keep them or not? Then you can keep lowering this threshold. So that's a way to diagnose large objects more conveniently.
And with sort of controlling the amount of impact that you'd have to your program. And another API that is sort of in concert for this is you can actually find out what the LOH configuration threshold is from the profiling API. Which is useful.
Yeah. So these are all things that we really wanted other customers to also give us feedback on, right? Because a lot of people, I know that people had told me that, well, you had GC profiling APIs, but we couldn't use them on production environment, for example. Which, the lightweight, you could totally use that on production. I don't think you can really detect any perf overhead.
Correct. I think the basic GC is something that if you could turn on, get that information essentially for free.
Right. So I think for the existing profiler authors, you have additional tool in your, available for you. And for people who used to avoid using profiling APIs for GC on their production, now they do have a way to do that.
Correct.
If they want to.
In Bing, we run with the basic profiling turned on essentially everywhere.
Right. Yeah. You also have plans to use, for example, the medium weight and all that.
And the medium weight is something that you can, for example, turn on as part of a leak detection analysis.
Right,
so you don't have to restart your program.
All the time. Right, you don't have to do it all the time.
Correct.
But
you can use this for that.
Yeah, so I think this would be really useful. It's a very useful addition to our products.
Agree.
Yeah. And as usual, you're welcome to give us feedback, opinions, and requests, whatnot, on Twitter. Our Twitter links will be down below the video. And I think that wraps up our walking down the memory lane, the 3 parts. So
it does.
Bye.
Bye.